Hello, everyone. I'm going to introduce my internship project now. As a simple introduction, CanDIG aims to provide nationwide distributed analysis platform of locally controlled private genomic data for different institutes. However, there can be a couple of difficulties around achieving this federated health data analysis. First of all, the same user can be granted different accesses to different data in different institutes. And there can be a lot of different data types and different data structures because of the health data's research nature. And even within one institute, the data can be stored in different data stores. And the health data can be very sensitive because of the patient's privacy concerns. And we chose to use GraphQL as our interface standard. But I'm going to introduce what is GraphQL first. So GraphQL was created by Facebook in 2012. It's a query language for APIs. It enables the exact fields extraction. So the user can define what fields they want. The GraphQL interface will return nothing more and nothing less than what they requested. And it also enables complex and flexible queries. So how is it different from REST standard? Because GraphQL was created as an alternative to REST, so there are a couple advantages over REST. It resolves some issues existing in REST APIs. First of all, it's overfetching. So in REST API, usually when client send a request to one single endpoint, the single endpoint will return a certain type of data objects back. So the client might download more information than needed, since some information in the objects might not be needed for the client. There's also underfetching issues. So one specific endpoint probably doesn't provide enough required information for the client. So the client might have to query from multiple other endpoints as well. Therefore, and GraphQL has one more advantage, that's it can bundle multiple requests into one. So you can avoid overfetching, underfetching problems in that way. And so why did we choose GraphQL? Because we try to do cross-service queries, and when joining data from the underlying data services, the multiple requests have to happen. That means the client usually underfetch from the data services. So that's an underfetching example. And usually there's more information than needed when doing data analysis. So when the client gets results from the underlying REST data services, that's an example for overfetching. So by using GraphQL, we can avoid both these issues and have a more convenient single access point for the cross-service queries. So how does GraphQL wrap around REST API data services? We use data loader, which is a generic utility for the data fetching layer. It also has memorization cache for all loads in a single request. So using the data loader, the data loader can send an API request to the underlying REST data services, and the data loader can feed the responses to the GraphQL internal code. So then the GraphQL logic code can deserialize and reconstruct objects from the data loaders. So there is a GraphQL sample cross-service queries. So in this example, we show that we can query from CanDIG server variants with constraints like the input will start one and is and we start as one and as and reference name as one, and we can draw in CanDIG server variants and cut individuals by their individual's ID. So in the GraphQL logic, you can just draw in them internally. And in this query, we chose to get sex and ethnicity from the Katsu's individuals. So as you can see on the right side, which is the results returned. So you will only return the sex and ethnicity fields from the Katsu individuals. So how do we implement these cross-service queries? We need to first introduce some concepts in GraphQL, which is schema and types. So GraphQL queries are basically just selecting fields on objects. As you can see in this previous picture, sex and ethnicity are fields for individuals. And schema is are available objects and fields available to query on the objects. And object types are the basic components that made of schemas. So in this example, the CanDIG server variance is an object type, and Katsu individual is also an object type. So this is a more lower level code. So we can see that this is defined as an object type, the CanDIG server variant. It has multiple fields that you can query, and you can select in the query. To enable the cross service, we have to use a function to get the Katsu individuals. We first load the individuals from the data loader. Then we can see if the Katsu's individual ID is the same as CanDIG server's patient ID. Then we deserialize the individuals from the data loader's result. Then the GraphQL will return the result. Is GraphQL secure enough? From what we've seen, GraphQL can enable a lot of different queries. However, GraphQL does not provide a built-in fine-grained authorizations. So we use a single decision point, which is powered by Open Policy Agent for all the underlying data services. So how does the single decision point ensure security? So this diagram shows that the user will send a request to the GraphQL interface first. Then the request will be forwarded to the underlying data services. Then the underlying data services will forward the request type and the user token to our single decision point. Our single decision point will return the allowed data sets back to the data services. And the data services will return the data with only within the allowed data sets back to the GraphQL interface. So in that way, our GraphQL interface will only be able to touch all the data that user has access to. So our GraphQL interface will be secure, and the user will only get the data they need and has access to. So we mentioned OPA, Open Policy Agent. So what is Open Policy Agent? It is an open source general purpose policy engine that unifies policy enforcement across the stack. So in the diagram below, it shows the usual flow for using OPA. So it's usually send a request to the service, then service will send the query to the OPA. Then OPA will decide and make a decision, then return back to the request. So OPA usually has two types of files. It has data, which is a JSON file that usually contains constants, and the policy is written in Rego. Rego is OPA's its own declarative query language to define policy that is easy to read and write. So in the following pictures, there are the sample code in Rego. So in Rego, it provides built-in decode and verify JWT functions. So in this function, it will decode and verify the token. And in the picture in the middle, that the valid token works as a function that returns Boolean. So you will check if the token is valid. The trusted research, it also works as a function will return a Boolean, and it will decode and verify the token, and as well as it will try to see if the token's trusted researcher field is true or not. And the username will be extracted from the token as well, from the preferred username field. And on the right side, it is a sample mapping we use in our to map the username to the allowed data set name. Yeah, that's how we basically use OPA to return allowed data sets. So there are also some additional works I have done for the GraphQL interface. I implemented some aggregate queries. So in this example, I implemented machine learning logistic regression model query. So in the right side is the GraphQL query. For the input, it has aggregate filter, which defines what field they want to filter on. So in this example, we want to filter on the phenol packets with contain disease asthma, and we'll try to see if it's dependent on its subject, sex, and ethnicity. So, and on the right side, it returns the logistic models parameters so that people can reconstruct the model. So what are some next steps? We hope to enable federated learning since our GraphQL interface can return a uniform format for the data, and it also can return a machine learning model, which means the institutes can contribute to the federated learning without exposing their own local data, and they will all be in uniform format. Yeah, that's it for me. Thank you so much. Is there any questions?
Yeah, that's great. Nina, it's really comprehensive. Everything from the GraphQL down to the validating tokens in OPA. Does anyone have any questions for Nina? So I'll ask some questions. So just out of curiosity, for these more complicated predefined analytical queries, like the logistic regression you showed, how complicated was that to, how much work was that to add as one of the queries that was supported?
It's not much more complicated because input filters are reused from all the other queries as well. The only thing is I had to add logic code for dependent variables, like to find what is to like to build a data frame like that has multiple columns, so that I can run logistic regression model on it. Nothing else is needed. Yeah. Oh, sorry.
Fantastic, great. Daisy, you have a question?
Yeah, so I was just wondering, my understanding then is that basically all of the underlying services don't actually, they just have REST endpoints, and then the overfetching will still happen on a local level, but the GraphQL loader will, interpret everything and then make sure that the user doesn't get too much after that. Is my understanding?
Yeah, that's right. So the client won't have this issue, but our GraphQL interface will still have to fetch everything. Yeah.
Oh, okay. Okay, that makes a lot of sense. Thank you very much, Nina. That was really, really helpful.
And Aman.
I have a small question about caching. There is a caching layer in the loader, I think, and so is that purge of the cache automatic when you update new data in the in the back end?
Yeah, it is automatic. It can be defined. But in our case, I defined it with it only caches within one request. So if one request needs to load something from one endpoint twice, it will only be loaded once. So the result will be cached. Yeah.
Oh, I see. And there are manual ways to purge it if need be. Because I'm asking because if we redeploy something.
It's
okay.
automatic. Yeah.
Ah, I see. Okay, that's cool. Thank you. Great stuff.
Great. What other questions do we have for Nina?
If I may ask, actually, yeah, could you get into a bit more detail as to how that machine learning algorithm was performed? You say it was a logistic regression over the clinical data in each institution, or is it one giant model that all of them share?
For that example, it only uses the one big one. Sorry, can you repeat that again?
Yeah, sorry if that wasn't clear. In hindsight, it probably wasn't even clear to myself. The model that you showed, or the results that you showed, that was for one model that would have been trained on one, let's say, one hypothetical institution, or
Yeah.
would it be the same, like in real world practice, would it be the same model that's shared across all institutions that would have been trained on every institution?
The example I showed only is model trained on only one institute's data, but in the future we hope to make a contribute to, so each institute will be able to deploy the GraphQL interface, and through some other federated learning framework, they can use that model to contribute to a centralized server that contains like a global model, I think.
Okay. Maybe I should look into that to understand the whole federated learning concept. Thank you very much.
No problem.
Fantastic. Any other questions? All right, great. Well, let's thank Nina for a very nice talk.
Thank you so much, Nina. That was really, really cool.
Yeah, that was fabulous. Thank you so much.
Thank you, Nina.
Yeah, thanks.
Great.
Very much appreciated.
Now I know who to ask questions about GraphQL. I know have a.
Thanks, Nina.
Thanks all. Bye, everyone.
Bye.